Okay, the 6-6 homework solutions for those of you that missed class. Number 1, use the graphing method. So when you graph to prove an identity, make sure that your mode is in radians. If your mode is in degrees, all right, use the down arrow, put the cursor on radian and hit enter. We can quit out of that. Y equals secant is the reciprocal of the cosine function, so we're going to have to plug that into the calculator as is. 1 divided by cosine of x, close the parenthesis and then square it, minus tan of x squared. In y2, I'm going to substitute 1, and then we hit graph. So it's working, and we only see one graph, so we know that is in fact an identity. For part B, clear both functions out. On the left-hand side, sine pi over 2 minus x. In y2, sine of x minus pi over 2. Graph. Fortunately, these graph quickly, and automatically we can see that two functions are being graphed. So this answer, yes, an identity, and 1B would be no. Alright, prove the following identities. On the left-hand side, I'll put sine x over 1. Rewrite cotangent as cosine x over sine x. The signs in the top and bottom cancel. Cosine x on the left, cosine x on the right. Done. B, cosine x over 1. Tangent, rewrite that as sine x divided by cosine x. They cancel each other out. I'm left with sine x on the left. We originally had sine x on the right, so we proved that. Part C, tangent, sine x divided by cosine of x times cotangent is its reciprocal, cosine over sine. The sines cancel, the cosines cancel. Anything divided by itself is 1. Then the Pythagorean, according to the Pythagorean identity, we know cosine squared plus sine squared is 1 as well. D, sine over 1, cosine, and then sine x over cosine x. The cosines cancel each other out. Sine times sine gives me sine squared of x. Now remember, you need the exact same thing written on the left as you do on the right. Squared trig function and a 1. Come back to the Pythagorean identity. So there's one of two things we can do here. If I want to isolate sine squared, I'm going to subtract cosine squared from both sides. Alright, so from this step, one justification that I can do, keep sine squared on the left, and then 1 minus cosine squared is equivalent to sine squared. Done. I could also keep what was originally written on the right-hand side, 1 minus cosine squared, and replace sine squared on the left with that exact same identity. Okay, so either method that you chose, they would be correct as long as you are showing same on the left as it is on the right. Okay. Alright, part E. Let's work on the left-hand side here. Sine x stays put. Sine x over 1 times cotangent we know is cosine divided by sine, but when the original function is being squared, you also have to square each individual function when you rewrite it. So this is what I would get when I just replace cotangent squared with cosine squared divided by sine squared. A couple things that I need you to see. You can't cancel the sign that comes before the plus sign with the sign in the denominator over here. We can't cancel across plus or minus signs. The only cancellation that happens here one sign from the numerator will cancel with one sign from the denominator. So then I have sine x over 1 plus cosine squared x over sine x. So now to prove, I'm asking you to add fractions together. In order to add the fractions, we know we need a common denominator. So the common denominator would be 1 times sine x, which is just sine. The second fraction, we don't need to multiply that numerator by anything because it already has a common denominator. But the first fraction, we need to multiply by sine x. Okay, because we always multiply top and bottom by whatever is lacking from the denominator. So sine times sine gives me sine squared of x plus cosine squared of x, all divided by sine of x. In the numerator, my Pythagorean identity. By the Pythagorean identity, I know that sine squared plus cosine squared is 1. So my whole numerator I replace with 1. 1 divided by the sine of x, that's equivalent to the cosecant of x. And that is the function on the right-hand side of the equal sign. Oops. So we worked on the left. We proved it was the same as what was on the right. So we're done. F, I would also suggest starting on the left-hand side, cotangent, cosine of x over sine of x, plus sine of x divided by cosine of x. Again, you can't tell me that these two cosines cancel, and you can't tell me that those two sines cancel. You can't cancel across a plus or minus. So, adding fractions, in order to add or subtract fractions, we need common denominators. Sine x times cosine x would give me my common denominator. Each numerator will need to be manipulated. The first fraction, I'm lacking the cosine function from the denominator, so that's what I'm going to have to multiply by. The second fraction, I'm missing the sine function from the denominator, so that's what I'll have to multiply here. Cosine times cosine is cosine squared of x. Sine x times sine x is sine squared of x. All over, maintain the common denominator. Pythagorean identity, again in the numerator, 1 divided by sine x cosine x. Now when we did this in class, most of you stopped here on the left and then you worked on the right hand side. The secant function is the reciprocal of the cosine of x. The cosecant function is the reciprocal of sine of x. Top times top gives me 1. Bottom times bottom gives me cosine x times sine x. Now we know the order in which we multiply does not matter. So on the left hand side, we can just change the order of the trig functions, and now we do in fact show that the function on the left is equivalent to the function on the right. And lastly, okay. Now when we look at this, so first thing, there's no functions to rewrite. Meaning there's no cosecant, secant, cotangent, or tangent function. So some people in class had asked, okay, well then how do I know where to start? If you refer back to our notes, there was a problem that had a difference in the denominator, and the hint was to use the conjugate. So we'll start on the right hand side of the equal sign here. So I'm going to multiply by 1 plus cosine of x on the top and bottom. That's the conjugate of the denominator. Top times top. So I had suggested not to distribute the sign, and the reason being, if we look at what is here right now, 1 plus cosine of x, I need 1 plus cosine x in my numerator on the final step to prove it. So don't distribute the sign, because if we're looking at the parts of the numerator, this sign should cancel out eventually. So I'm going to leave it in factored form. My denominator, I'm going to FOIL. 1 times 1 is 1. Positive 1 times cosine of x. Negative cosine of x times 1. A negative times a positive. My last product will be negative. Cosine times cosine is cosine squared. We pick the conjugate because these two, the outer and inner terms, will always cancel each other out. Oops. So now I have sine x times 1 plus cosine of x, all divided by 1 minus cosine squared x. So we're close to what we need the left to look like, but I need to get rid of the sign in the numerator, and somehow I need to introduce a sign in the denominator. So if I look down here, squared trig functions and a 1, you should always come back to the Pythagorean identity and see if you can manipulate this equation in any way. I need 1 minus cosine squared x. So from the identity, I'm going to subtract cosine squared from both sides. Now I can use this fact and rewrite the denominator. Keep the numerator in factored form. Sine x times 1 plus cosine of x. I'm going to replace the entire denominator with sine squared of x. Now, because the numerator is in factored form, 1 sine from the numerator will cancel with 1 sine from the denominator, leaving 1 plus cosine of x in the top and sine x on the bottom. And that's exactly what the original left-hand side of the equation was. If you missed a homework quiz, please review these and be prepared to take the homework quiz in class.